let's start with this double lecture given by Mateusz
No, it's not
Zwierzycki.
double lecture.
No, it's going to be double. You're allowed to make it double.
Okay.
Don't worry about that. This year for me has been a year of Mateusz. I met him so many times this year already. It was so nice to meet you. Like, this is the 4th time this year, at least.
Yeah, I think so.
Yeah, it's the 4th time. Amazing.
Yeah.
This is,
That's sarcasm, if you don't know.
yeah. This is one of my closest friends that I like the least.
Should I go out though?
No, please. You've been like this to me the whole day, so I somehow need to come back at you.
Okay.
No, I'm really happy that you came here. We've been planning this event somehow together for a long time. You also helped me a bit with the selection.
Yeah.
But still, we've been talking about this event, and you immediately, when I mentioned that I'm planning something like this, you immediately said that you are going to be part of it. But the same applies to Aldo, I have to say. We always keep this conversation coming. We actually, we were teaching one workshop only together, but we then, we organized one of the KUKA labs together. You were the first one to use our KUKA here, and it seems like I'm the most eager user of your plugin called Anemone. Maybe not the most eager, but definitely I use it in every single Grasshopper definition that I make because that makes life so much easier and better. And I'm very happy that you made it when you first were designing the Anemone. You gave it to me for beta testing, and I had a chance to influence somehow how does it work. Yeah. And I have to say, I requested a couple of some functionality.
And they never came there. No, I skipped them.
Some of them were implemented. I just never used them. So I really insisted you have to put that thing there because I need it. Never use it. So.
Yeah.
But I'm very happy.
Sounds like you.
Yeah. Sounds like me. That's true. Anyway. You're going to have 2 different topics, as far as I understand.
Yeah, I will try to merge them. I mean, I think I will. I hope that I will succeed with merging them together, because I'll try to make it continuous. Yeah. In a way. I mean, there won't be any break in between. So, and I try to make it like cover it both after the same, like below the same roof. So.
Okay.
Yeah. So
maybe speak a bit up,
yeah.
Because even though you've got a microphone.
Yeah.
You don't have to start that because I'm going to check your time, and if you are too long, I'll come.
I'll
tell you that you're boring and you should stop.
Do that. I mean, like, I mean, like Michael always says that he like falls asleep when I talk during the workshop, and that's.
No, that's actually a skill too. So
yeah.
When I have problems falling asleep, I would just run some of your videos.
I mean, that's why you did the webinars.
That's why I do the webinars.
Yeah. Okay, so thank you for the introduction, and thank you. I'm not sure if I should actually thank you. You're a bit mean. Okay, so let's start with that. It's a nice picture, isn't it? I mean, it was rendered by Jan. The geometry was made by B. It was like some kind of L system just to test out. I guess it was testing out the Anemone itself. And the problem is that this presentation is not going to be about that at all. Because exactly what Jan said, what happened when we first started to talk about this meeting was, I was like, why? Like, you know, Jan, that for now I'm doing something a bit different. And I'm not even like, you know, my background is like generative. I did this stuff for for a very long time, and I've been like developing Anemone just to do that. So like developing my own tools, and I mean, but currently, I mean, I'm not really that much into that anymore, because I have like, you know, like a job, like a big projects, stuff like that. But then I actually realized that it's all really, really well connected, and the particular skill set which I somehow learned over the years is actually projecting onto what I'm doing now. And I think that it might be really inspiring in a way for you, how it can project onto different things, and then how it can actually, those different things can project back onto what you're, like what I'm doing. in a generative way. So yeah, so let's start with what I'm doing now at CITA in Copenhagen. So this is a project which I was hired for. I mean, this is like a big European project. There are like, I think 7 different universities and companies into that. And then, yeah, it's huge. I mean, I'm only a small part of that. I was employed only for the last half of the year. This is this half of the year, and it's going to end in January. So what is it all about? It's the DuraArch. It's like a durable architectural knowledge. So the main task is to archive the information and operate with the information about the building and environment. So those are big words actually. So for instance, we operate mostly with BIM data and 3D scans. I mean, I know that it's not generative, but wait for it. Yeah, that's the current life cycle of building data. You have a design planning. I mean, I don't know which way to start actually. Just design, planning, production, operation, archiving, and then you have the design again. So it is the BIM data. It's not the building life cycle. It's just the building information life cycle. And then you know that BIM modeling is not really that old. So now in some moment we are going to run into a problem because stuff which is already here, it's not going to be compatible in the future, and then we have this big part of data which we don't really know what to do about. And that's probably one of the reasons why we are actually doing the DuraArch project. And you can see that there is a major retrofit, and then again we have this whole life cycle of the BIM data. And then we have like a big archive of this data and big archive of 3D scans, and we try to merge it somehow because, you know, that's the archiving thing. And we try to operate with this data constantly across probably many decades. Yeah, it just started. So the tools which are there, they are not really there yet. We run into many problems anyway. Yeah, so there are like main questions: how to maintain access to information, how to trust the information, how to use the information, and this is probably this is probably the foundation of the whole project. So if we are talking about BIM data and about 3D scans, of course the 3D scans are now here and they are very precise. We have machines which can do that, like laser scanners or Kinects, and whatever we can think about, we can archive this. We can operate with the data even though this is kind of a big data. Yeah? So for instance, we have files which, like one single file can have 60 gigabytes and it's only one scan. Yeah? So I mean, actually it's merged from many scans, but it's only one scan which is like 60 gigabytes, and then we don't really like what do you even do with that? And of course there is there is a whole 3D scanning industry which operates with very expensive like hardware, but then there is the democratization of the hardware, which is like the Kinect, and then some more upcoming things. I just recently saw I think it was Harvard or MIT project which took the data from the Kinect and the photo, and actually the photo was they polarized the light and filter out the polarization of light and so on, and they actually generated a much higher quality 3D scan out of Kinect than from a commercial 3D scanner, just by managing the data properly and like the 3D scanning properly. So so that was what happened, and that shows that it's going to be here with us. I mean, the 3D scanning part. This part of data which is there, and the retrieval of data, archiving the data, is something that is very important. So so that's why this project has to be, because we want to find solutions for that. So yeah, so if we compare, I mean, I'm talking about BIM and point clouds at the same time, because now we are getting to the key point, which is how to, like once you have a 3D scan, how to actually get some information about out of that. Yeah. So of course 3D scan is just the geometry, but then there is the whole layer of information of what it actually is in the 3D scan. And you have a semantically poor and rich data. Poor is the point cloud, rich is the BIM model, where you have actually every single thing described, precisely what it is, what's the thickness, what's the material, who's the owner, and whatever you can think about this object is going to be described. So yeah, so just to give you an overview, there are like seven big universities, and I think Catenda is actually a company, but anyway, big partners in this big consortium. And it's again, I think Johannes is also Framework 7. One of the projects was from the same European Union budget, so it's also part of that budget. And yeah, so so we have those people with us, and we are only a tiny part of that. Like, I mean, CITA. But I think we are the only architectural department which is into that. The rest is computer science and some other guys, but I will be talking mostly about the computer science guys and the stuff which they are doing. And then I'm going to show you what we are doing as CITA. So in this whole scope of retrieving the data, operating the data, and then putting back in the archive or in the like real world use and what you can actually get from this data and how you can use it, we have this whole chain of actually those different functions which you have to have. And then there are like components from the workbench, because we have a workbench which is like a particular tool set. Yeah? So everybody is doing something different, but together it's going to merge together, and actually it's already there, and be one single, let's say, workbench, exactly. Yeah. So we have the components here. And what I wanted to say, yeah. So we as CITA and I'm just going to see, yeah, okay. So we as CITA are scattered around, I think, most of those topics here. But then there are more precise researchers who are trying to develop some tools which we can then use and implement in some other layer of the software. So yeah, so this is just a reason why we want to get point cloud and make a BIM out of that automatically, because that's the first part which is developed by computer science guys. I think this was actually University of Bonn. I mean, Technical University of Bonn. So that's the first part which I was talking about, and that's how it works. I mean, of course, there's like a lot more there, but that's what you get. You start with a series of scans, and then you just click a button. It's a magic button. It's called magic button now, and you just get an IFC file, which is like industry standard file, and you can just take a BIM model and archive the BIM model. And you basically can forget about the point cloud. I mean, still it's there, and still you can use it. But if you want to see what is there, you don't have to, download hundreds of gigabytes of data. You just have the BIM model, and you know what it is. So, yeah. So then, what you can actually do with that information, once you know what it is, once you analyze the point cloud, you can actually get some more information, like the topology of the building, like here. And then there's like another part, which is another part, which is difference detection. It's also a part of, I think also it's also done by guys from Bonn. So what they do here is actually they take a BIM model and point cloud, and then or point cloud and point cloud, or the other way around, whatever combination you want, and then there you have the difference detection between the different parts of the building. So you can compare it to different scans, and you can see what happened over the time. And yeah, and then you have also another project which is inside of our Duraarch workbench, and this is actually using some generative techniques, which I just want to point here. What they are doing here is they're using neural networks to recognize outlets in photos and in 3D scans, and then what the neural network and the whole tool does is actually trying to imagine how could the whole cable network be run across the building. So they are using actually shape grammars to generate different solutions. So this is like purely generative technique, but combined with machine learning technique, which is neural network and recognition, and then actually optimizing the path of the cables. So of course, this is one example of usage of machine learning and generative, and outlets are outlets. But then, if you think about it, it actually can be combined with any kind of infrastructure which is there within the building. So if you have any HVAC or something like that, you can still use that tool, and you can still generate something. And of course, if we, the computer doesn't know that outlet is the outlet. So this tool can be used in multiple ways. It doesn't really, it doesn't really rely on purely on the outlets. Of course, they used a lot of data to train the neural network to recognize the outlets. So you have to have a lot of pictures of outlets, different outlets, like UK outlets, European outlets, and then from every different angle on every kind of wall which is there to imagine. And they have like, I think, thousands of different pictures, and also artificially generated pictures just to train the neural network to recognize the outlet. But once you have it there, and once you recognize the locations, you can actually generate a map of those outlets and generate, the different hypotheses of how the network could be actually created. Yeah. So you can see those axes here, and then those axes are actually some hypotheses of how the cable network should actually run, or something like that. Yeah. I'm actually missing one picture, but anyway. But you see that there is a connection between those generative techniques, which is in this case like a shape grammar tool, and machine learning, which is always in the background of this project there. And I think that is a really nice connection. Volvox is a new plugin for Grasshopper, which tries to integrate those workbench components into Grasshopper workflow. And it actually turns out pretty nice, because we actually, sorry, oh yeah, that's the end of the presentation. So I'll just show you the video. I mean, there is a bit more there. Yeah, so Volvox is actually some kind of plugin which resulted from my experience with Anemone and with Squid and with those other plugins, which I of course cannot remind now. But as you can see, like, this workflow is actually a bit inspired with Squid, where you generate one bitmap over time. The problem with the point clouds is that this is like a big data, so you want to put it in your computer memory only once and not copy it all over, just like you do with data in Grasshopper. So there is the engine, and then you create a set of instructions. You basically you click the button, and let's wait. So that's the workflow. You can see I just want to take this point cloud and crop it, and then I know whatever to do with like rotate, move. Then you just click a button, and it actually works. Yeah. So then that's how it operates. So the thing with this, wait, one moment back here. Wait, I just want to pause it here. So you can see that this. Okay, it's a bit dark now. Anyway, so you can see that this workflow is purely inspired with Squid. If you know Squid, you only have this point cloud once, and then there is this transformer component which takes a set of instructions and proceeds them inside. So it has like a own simplified Grasshopper solver within itself. Yeah, and there is a library which you can use actually, and you can create your own instructions for the engine. So it's purely inspired by Squid, and that's the way I think that my input to the Grasshopper community projects into that. So it's like purely inspired by that, and yeah. So then during the project I learned quite a lot, because we were like asked for multi-threading. So that's something that I think that will result in the future in some other things which I will probably do with multi-threading, because now we are using the multi-threading, so we will just see how we set up the multi-threaded point cloud processing in here. Okay, so we have one point cloud, which is a big one, 6 million points. It's not really that big anyway, but it's just for demonstration. And then you actually split it into 8 parts. My computer over there has 8 cores, so that's why. And we'll just set up one engine which is there, like with one instruction, which takes a bit of a time, which is like spatial subsampling, which makes sure that there are no 2 points closer than some threshold value. And then you run it, yeah. So every component actually runs its own thread in the background, and every component takes only one piece of point cloud, and that way actually every engine actually runs only one thread. So you can utilize 100% of your CPU there. Yeah, so I think, it's point clouds, but then I think like I'm really inspired with that, and I really know that it's possible in Grasshopper to do multi-threading. Like, everybody says it's not possible, but everybody said that looping is not also possible back then, yeah, and then hoopsnake happens. So, and yeah, this is another tool which actually, there was this part of mesh tools where I created voxels, and then we just came with this idea. I mean, it was actually inspired by one paper, which I cannot credit now because I don't remember the title. But it was, we modified it. It's actually our version of the algorithm which was there. It's actually completely different anyway. where we voxelize the point cloud, and that way we can actually color the point cloud, and it's a watertight mesh, so we can just put it in the powder printer, print a colorful print out of that. Yeah. So, okay. Okay. So that's yeah. I just wanted to point you that those tools, like you saw, like Volvox was purely inspired with this kind of memory limitation, but also with what I've already done with Squid and how it operates. There is the same workflow, like the same framework, the same architecture of taking a set of instructions and actually processing the data only once within one component inside of Grasshopper. And yeah, and I think that it's nice to, like, given my background in this generative field, I feel that it actually makes like this knowledge which I have from back then actually really nicely projects onto what I'm doing now. And I think that those tools are going to project back on what we are going to do in the future, because I want to actually ask you to use our library, because it's very nice. I mean, like the Volvox itself is actually 4 different files which you get. One is the library which enables you to just get the point cloud there. Then there is a second library, which is a library which enables you to create your own instructions just for the engine, so you can use the engine and don't worry about the multi-threading part. And then there is the GHA, which is just components, and then there is a Python one, because we actually use some Python there as well. Like, it's a big project, actually, like the plugin itself. And yeah, and that's conclusion of the first part, but also I just wanted to show you. Oh yeah. Now the Rhino part. Yeah, of course. Okay, so I just want to show you how actually you can use Volvox library in Grasshopper, and probably some of you who we are friends on Facebook with saw it already. So I'm just going to show it again. But yeah, on Facebook it's a bit slower because I had to record it. So let's see, like this is Anemone here, and this is a big point cloud. This is actually point cloud from the Volvox library, and I do here like a very simple cellular automata, which is like oscillating cellular automata, and it has like 125 points. Yeah. So let's run it with Anemone, which is not like a speed demo anyway. Okay. So this is like 125,000 points on my laptop, which is not the best laptop ever, and it just runs now. Yeah, so yeah, I just did like 100 loops. So let's move again. Yeah, so this is like a very simple use case for point clouds in Grasshopper, and you see, it's not about building anymore. I mean, that's what I mean. How it projects back onto what we can do with those tools which are developed there, and how we can be inspired with each other. And yeah, I can do million points. Let's do million points. It's a bit slower there then. Okay, so let's do. Yeah, that's my sound. Okay. Yeah, there is like some display issue which we are fighting with, but there's like million points on my laptop in Grasshopper doing cellular automata. Cellular automata is actually multi-threaded as well, so that's another projection from one field to another. The script is just here, and I can just show you the script. Like 90% of the script is just handling the multi-threading. Okay? So that's the script, which is just using this multi-threading, and then yeah. I mean, we can discuss it maybe tomorrow if you want to see how it's done. I can show you how to use the Volvox library. So I know, if you want to use any kind of points in Grasshopper, you know that it's really painful when you get over like 10,000 points. So I think it's really, really nice to actually be able to run the cellular automatas for like this kind of big collection in Grasshopper in real time and with Anemone, of course. So. Okay, so yeah, and yeah, I'm really open. Like tomorrow, if you want, I can show you how I coded this one. I can also show you how we did. Yeah, I'm not going to run a workshop anyway, but if somebody is interested, I already talked with some of you that you would really I know that people would like to see it. Like some of them. This is just generating points and assigning random values. Then it's packing it in the Grasshopper wrapper, which is like a class in Grasshopper, which enables you to exchange data between components. But then the main component is here, yeah, and it's all the setup with the multi-threading and with the point cloud, with the Volvox library and so on, and just runs like 1 million points with this cellular automata here. So, And the display is really nice. It sometimes flickers, but I'm not really sure why. And it was done during, like, I don't know, half of a day. Because yeah, I'm multi-threading within one component, and the Grasshopper is usually quite painful because you have to know what to care about. Grasshopper has its own workflow, and then sometimes it's hard to follow. But yeah, I'm open to any questions here. Okay, so now we have Anemone, and if some of you know Anemone, that's another update on what I'm doing now, Anemone. If some of you know Anemone quite well, you know that this was not dashed line, it's now dashed. So, oh yeah, and here we have the Anemone tab. So let's take a look at some kind of classic problem with Anemone. That's the next part. I just want to switch now, but I mean, you see the connection, like Volvox Anemone and now Anemone itself. So let's focus on Anemone, and just gonna open this definition. Here. Okay, so this is a classic thing which we did with Anemone all the time, because it was like every workshop we did on Anemone was always about, you know, just introduction, how to use the workflow. And it was a good example, the light relaxation algorithm, which is like very simple. Yeah. So this is Anemone, which is more or less the same, but those two components are. This is just Anemone 0.26, which is there, but it's just cleaned up a bit. So that's the new release. But then we have, yeah. So you see that it runs like it runs. It takes some time. But now there are like few more components there. So we have a fast loop start, and this is like, I really missed that Robert is not here, because they developed the Octopus, which was really like getting me down, because they developed Anemone, like another looping plugin, because I have to be honest, like I'm not the first with looping, Hoopsnake was. So they developed like a looping plugin which did it like much faster. So I was thinking, yeah, I should do that as well. So I did. And this is the new Anemone here. And it has the same kind of layout. It misses some inputs, but those are like minor inputs here, because yeah, they are not really required anymore. And you can see that this relaxation took some time. So I'll just run the same exact data on this new Anemone there. I'm just gonna connect it here, and it's here. And yeah, so there's like 100 loops. Yeah, so let's cross fingers that it doesn't crash, and done. Okay, so that was 100 loops with new Anemone here, and yeah, it took like 1 sec, less than 1 second. Okay, so you see that there is a huge speed up with the new release, and basically the interface is the same, and there are like some cleanups, like cosmetical stuff, like you can rename the inputs, and after adding a new one, it actually doesn't rename the one which you changed the name. So like these things that I was asked to do, well, by many people, like users of Anemone, and yeah, there is the fast Anemone. But then there's like another Anemone. There are like 3 of them now. So yeah, so let's get rid of, I guess, that part. And that part, and yeah, let's leave this here. Okay, so I'll just take those 3 components, I will create a new definition here, and I will use the new internalized panel, and let's create those 2 components here. And here. So you can see that this is like loop input and output here, and I'm creating a new file, which I'm just going to reference in some other definition, and you'll see what happens. I'll just rename it here, so it was like points in and points out. And yeah, so let's save the file, and it's okay, just Bratislava. We renamed the file. I'm just creating a new file now. And what I can do is I can take this component, right-click it, and assign a Grasshopper file. And I'm going to assign the Bratislava. So you can see that it actually took the file, and now the loop is stored inside. So we can run the whole relaxation inside. And if I just take this component here, let's go back here. I'll just put it here, yeah. So I just took this part of definition, copied it into a new file, rewired it with loop input and output, and now I assign it to this third component, which just takes this input, takes this definition, and it actually serializes it, and it's internalized all the time. So it's inside there, and now we can actually send this component to somebody else, and it's saved there. So the definition, you don't have to send the definition. What we can do now is we can actually take this part here, and take those points which are here and take them out here. Okay, now we have the I input, which is just 0 now, so it just passed the data once. And now we have like 100, and it also takes those 900 milliseconds. Yeah, so yeah, you don't really have to have the file anymore. We can basically delete it. So if you're familiar with Grasshopper, you know that there are clusters. This works a bit different. I will just delete the file so you know I'm not cheating here. Yeah, so yeah, I tried to make it nice so it just renames the component to the name of the file. The inputs are here as well. Also, if you name one input, which is if you will take some component, I don't know, geometry. If you will name the input like that, like input or output, if you name it hidden, it won't appear in this component, yeah. So you can have like one input and some data stored inside which takes part in the loop, but you don't really have to expose those parameters outside. Okay, so now you can send it to someone, and someone will be able to run the loop internally. Yeah? So that's like a cluster, but it's not really a cluster, yeah. It's actually made up from scratch. I mean, not really from, I'm using a lot from Grasshopper, but it's a hacked way of clustering. And it's decoupled from the file. So what it means that if I right-click and edit the file, it actually opens the unnamed file, which is a new file. It just copies this definition, which is stores internally into a new definition, and you can edit it. And the idea is that you save it again and add a new run loop, which is here. Or just maybe I'll just no. The idea is that you save it again. Take a definition, which is here, and use the same run loop. Right-click and assign this file again. And yeah, that's the workflow. That you don't have a linked definition like in clusters, because I'm not really a huge fan of clusters with the linking. And then also that way you can actually send this component to somebody else, and somebody else doesn't have to have this definition. Yeah, I mean the same is with clusters. I mean, I'm just not a fan of linking the files and then not being able to track what's going on, and when you update the component, what actually happens. You can actually take this component and create like a user object with that as well. So it can be like stored there. And yeah, there are many new features, but nice one is the password. So if you take this definition, which is here, and you just put the password here, component, you can just input it here, and let's say write something like, oh come on, oh no, let's do like the standard password. Yeah, so this is like the password. Okay. And now I will just save this definition, and I will just try to put it somewhere else. Okay, and now when you want to edit the component, you actually have to put the password there. So it works more or less like the password in clusters, but that's the idea, to copy the clusters and actually loop them. So that's how you can access the file. Yeah. So if you take this definition, if you don't know how to, like, yeah, if you know Grasshopper very well, then you will know how to get this password out, but it's not as easy. It's not really easy. So it's like, it's kind of safe. It's the same with clusters, yeah. So that's how it works. And yeah, and the last thing which I wanted to show you is the link, which is here, and you can download this Anemone right there. So if you want to download it, you can download it there. Thank you.
Thank you. Oh, I need to switch this on. save some battery. You promised that you will be longer.
I tried to talk fast.
Okay.
I don't know if you noticed. I was really fast.
Yeah, that was really fast.
Yeah, I know. I tried.
Couldn't even follow. I couldn't wait for the announcement of the new Anemone, and I somehow missed the point where you actually officially announced that.
Oh yeah.
I hope there was some
now.
or something. Because as I told you, I use it all the time. But it's really slow. But now it's really fast.
Yeah. I mean, of course, Octopus is also fast, but Anemone is Anemone, and I think that all those 3 different plugins have, Hoopsnake, Anemone, and Octopus have a bit different application and a bit different pros and cons, but I tried to make this one the best. No, it's not.
Then I will probably have to somehow rewrite the Void library as well. Mainly to work with Volvox, that would be actually
that's
quite good.
Yeah, I think like you can see with the Silver Automat, like 1 million points, and they are just looping with Anemone. It's like, I was amazed actually when I discovered that I can do that, because I was struggling with Silver Automata for so many years. I mean, like, just to run Silver Automata in Grasshopper, if you try to do it like more than 10,000 points, it's just really slow. It just that's because Grasshopper, it's not really slow. It's just the whole user interface, interaction with the user, events, event handling, and display handling, and Rhino interaction handling. It's really slowing it down. So once you get rid of all of that, it actually speeds it up. And that's how it works. Yeah.
Or maybe somebody finally will tell me that there was enough voids already, and we should move on to something more.
I can tell you that. I mean, I can tell you that.
You can tell me many things. I know that. Okay, now Q&A session. They should ask, you should answer. That's just questions from that side, answers from this side.
Is it instruction for me or for them?
Yeah, for you.
Okay.
They know.
I just have a curiosity. You seem to have a lot of experience with the scanning, which I really haven't talked to that many people about, and I'm fascinated with things, especially its transferring to VIM. That's fascinating. But so how much can we currently get like materiality information out of a scan?
Do you mean like?
That's wood, or that's, you know.
No. That's as far as I know, because the project is really big, and I'm sorry, I forgot to credit guys from Fraunhofer Institute. Those are the guys with the outlets, hypotheses. I mean, that's the 2 first parts were Bonn guys, and then there was the Fraunhofer. It was like there are like guys from Fraunhofer,
so
and
it takes that kind of image of it, and then it analyzes it.
Yeah. And it's using, the funny part is using actually generative technique like shape grammars, which is so cool, which, because then you have like, I'm just going to elaborate a bit about it, because I'm really fascinated with that project, because it's like, you can imagine that you have one shape grammar, and then you switch to another shape grammar, and instead of outlets, it's probably like in some other country, let's say that the culture of outlets is to go across rather than in right angles. Then you can just switch the shape grammar, and it will work the same. So, if you ask about materiality, because I think that was the question. No, as far as I know, there is no thing like that. But I can imagine that it could be a part of that. And already there is a huge, it's already 2.5 years of development, and there's already a lot of things done. And I think that this thing is, it's a nice question, because it also gives us an idea of what can it be in the future.